Hey guys, welcome back to the lab. Hey folks, welcome back to the lab. Hey folks. Hey folks, welcome back to the lab. I decided to get technical about the resin because my latest socket was too much of a success. So I need to learn more about how it gels, and the only way to do that is by experimenting with the resin to catalyst ratio. So I got a little setup here which I'm going to go through right now. Although I'm really pleased with the way my first attempt at a socket came out, I did make several mistakes. For starters, it's way too thick, and this part won't flex no matter how much I try to tighten it. I drilled in some holes for shoelaces, I drilled some holes for laces, but it still won't flex, and this is 5 layers thick. And this is 5 layers thick. The socket itself is very, very good, but it's just not flexible enough down here, so I'm going to make some. And since I'm still not an expert at working glass fiber, well, this isn't glass fiber. Since I'm still not an expert at working with resin, I'm going to take a scientific approach to it. So I weighed out about 1/8 of an ounce in each one of these little trays. I also labeled them. This is the control tray. As you can see, if it focuses, you'll see it has 3.5-ish grams, which is about 1/8 of a mass ounce. And down here, I have 5 little trays, which I labeled 1 through 5, and I'm going to experiment with different amounts of catalyzer in it. An eighth should work out to about a drop per tray would be the standard formula-ish. So I'm going to try 1 drop, 2 drops, 3 drops, 4 drops, and 5 drops, and I'm going to leave the control alone. No catalyzer. But like I said, I'll be adding 1 drop of catalyzer on this one, 2 drops, 3 drops, 4 drops, and 5 drops. And we'll see how well they gel. Because they don't seem to gel as fast as Ian's resin. Because they don't seem to gel as fast as Ian's resins did. So these third world resins might be a little slower to act. I don't know. But like I said, I gotta get scientific about it. But like I said, I gotta science this, and yeah, just be disciplined and organized. Yeah, I gotta get organized and test different amounts of catalyzer for this specific resin. I think it's going to be time well spent. Once I have a decent gel to catalyzer once I have a decent resin to catalyzer ratio, I can start worrying about the new socket, which might not be made entirely with socks. I might make some pantyhose layers, and like I said, I want to add this, the T-nuts. So, see you in a while. Hey puppy. Guess who's here for a visit? He's curious as Kathy was. Okay, so here goes. 1 drop. 1. 2 drops. 1, 2, 3 drops. 1, 2, 3, 4 drops. 1, 2, 3, 4, 5 drops. I probably should have done it one at a time, but I live dangerously. So, let's stir this one up thoroughly. Oh boy, I think these polyethylene trays are not gonna hold up to the gel. I think I felt it soften at the bottom. Yep. Ian recommends polypropylene plastic trays and mixing cups and stuff like that. I'm using polyethylene and I can feel it soften under the resin. There's a chemical reaction going on there, no doubt, between the polyethylene and the resin. So, somewhat of a fail there, but okay, this is the 2-drop tray. I'm going to try not to stir and dig into the bottom. I don't know if the fumes are harmful, but oh wow, they can get to be nauseous, to say the least. Okay, tray number 3. Is there a difference in thickness? Not sure. Is it gelling up faster? 3 drops? I'm not sure. Actually, it might be that the resin is thick as it is. Since I placed the drops in the center, feels thick until the drops dilute it. And then it starts thickening again when it catalyzes or something. I don't know. Okay, so there's tray number 3 with 3 drops of catalyst. Tray number 4 is 4 drops of catalyst. It's changing from that yellowish polyurethane color it had to a sort of amber brownish now that it has the catalyzer. Or is it shadow play? Yeah, it's shadow play. Forgot what I said. Just trying, it's like derived properties and stuff like that. I should probably put this on a board or something, because if there's a reaction between the resin and the polyethylene, and it eats through, at least the mess won't be that bad. Get that once I'm done mixing. Okay, that's 4 drops per 1/8 of an ounce. And here's the 5th tray. 5 drops per 1/8 of an ounce. Can't tell much of a difference yet, I guess. Too subjective at this stage, anyhow. Okay. Jeez, this stuff smells. Ugh. So here's our experiment. Here's our experiment. They look nice. Yeah. Okay. So let's see. The time is 8:52 a.m. Christ. There we go. 8:52 a.m. Let's see how long it takes for each one to gel up. This is going to be a cool test. I should have done this last time. Oh, and here's the control tree. Oh, and I did promise you guys I'd move it to a board or something in case we have a happy little accident. You guys remember Bob Ross? I highly respect Bob Ross, okay? I highly respect Bob Ross. I highly respect Mr. Rogers. I don't know. Decent guys. And this world needs more decent people. Okay, and let's not forget the control tree. I'll do this strip later. I want to slather it with resin. I've been saying that so much. I want to coat this in resin and see what happens. Okay, anyhow. Here's the whole shebang. I'll be trying to measure it every time I remember. Let's say I did all this at 9 a.m. I'll try and remember every hour on the hour. I gotta set alarms for that. Okay, so I'll see you guys at 10. It's only 10 minutes, I know. I know I said I'd be back in an hour, but it's only been 10 minutes and already the effects are stunning. Here's the tray with 1 drop of catalyzer. Can you see it's sort of like scooting everywhere, and it's not really gelling at all. you see that? Yeah, you can see that. See? So that's one drop. Whoops. Doesn't seem too bad on the underside. Here's 2 drops. Let me remind you, this is at 10 minutes. And see, it already looks gooey and stuff like that. It's, wow, it's impressive. And that's 2 drops per 1/8. Here's 3 drops per 1/8 of an ounce. And it's already sticking quite heavily. See? It's still liquid where the air hasn't gotten to it, logically. Here's 4 drops per ounce. And that just came off. It's still liquid underneath, but there. That's 5 drops per ounce. Not per ounce, per 1/8. Is rubbery, is what I can call it. That's 10 minutes. I'm gonna have to check it at 20 minutes. That's impressive. That's really, really impressive. Welcome back to the lab, folks. Okay, so 20 minutes after combining the resin and the catalyzer, number 1 is still very liquid, as you might be able to see. It might even spill out of the tray. See the viscosity? That's the standard ratio. This hardened in about a day and a half when I did the sock thing. That's the same ratio I used for this. And it took about a day and a half to harden. Okay, here's 2 drops per 1/8. And it's still quite liquid at some parts, but it's getting there. That's double the amount. That's double the prescribed amount. Here's number 3, 3 drops. It's already, wow, it's pretty hard. It did affect the polyethylene. It did affect the polyethylene. I don't know if you guys can see. Oh yeah, it went through right there. See? Yeah, it poked through the polyethylene. That's why it has to be polypropylene. Because it seems either the resin or the catalyst reacts with the polyethylene. I just lost a piece. There it is. See? But, wow, it's curing. It's curing. Okay. Let's proceed with number 4. And again, it did affect the polyethylene. Again, it did affect the polyethylene. I was a bit more gentle, so it didn't tear through. And this one's pretty solid, though. Number 5, whoops, sorry about that. That's why I'm not showing you the control group. Number 5, wow. It's still sticky at the bottom. I'm sure if I leave it upside down, which I should probably because it's destroying the tray. Yeah, that's pretty much solid. See if I can do the same thing upside down. not just to preserve the tray, but to allow oxygen to reach the lower parts. Number 3 is like hopeless because it cracked, but I'm going to try my best to fix it. Not even sure it's worth it. Let's leave it. Let's leave it be. Still part of the experiment. So, wow, it's generating a bit of heat. Number 3, I can feel it. Wow, it is. That's not that hot, but you can feel the heat. Try to make a little square of it again. I don't think so. Okay, I think I saved it. That's number 3. Oops. Trays aren't holding up. Number 2, I'm going to leave it alone because it's still pretty liquid underneath the surface of the... And number 1 is just starting to gel up again. But by far, 3, 4, and 5 are impressive at 20 minutes. See you in 10 minutes, guys. And here we are back at 30 minutes, as usual. Let's start off with number 1. I thought the plastic trays were being damaged because of the exothermal reaction. I thought it was the heat damaging the tray, but I can see in number 1, which is pretty much cold, it's damaging the tray. It's still liquid, but yeah, like I said, there's no heat and the tray is still damaged. I feel it bulging. And yeah, like I said, I could poke through it, so I'm going to be gentle. Anyway, polyethylene and resin, they don't mix well. Actually, they do mix well. And that's why you don't want to use them. Okay, number 2, which is 2 drops to the 8th, is getting hard. Yep, there it is. It's hardening. See? The underside is still, I think I can turn this one around because I poked through it with my finger, actually, or rather I'm making a mess here. So let's leave number 2 upside down. Number 3 is still sticky. It's not warm anymore. Number 4 is less sticky. It's a bit warm, but wow. Wow. See? Number 5 still a bit sticky. Okay, guys. This is at half an hour. I'm pretty satisfied as to how they're hardening. I don't think I need to check it every 10 minutes anymore. I'm going to come back in half an hour. The time being almost 9:30 right now. So I'll be back in half an hour from now. And so from now on, we're going to be measuring these every half an hour. So from now on, we're going to be testing these every half an hour. See how they harden. Okay? See you at 10, guys. There's one more thing I wanted to show you guys, and It's a length of timing chain from a Kawasaki KLR. A friend of mine called Jonathan got me, and I was thinking of using it for the fingers, but it might be a little too wide. Now, my country is plagued with cheap Chinese motorcycles, and the timing belt on those might be a little finer than this one. So I'm gonna see if I can procure myself one. Hopefully it's lighter. Okay, it's 10 o'clock. It's been half an hour since the last time we checked. Let's start with sample number 1 again. It's starting to gel out. Pretty neat. See? I can start lifting it. Not much of an exotherm going on. Whoops. Sort of stuck to my finger. Number 2, of course, is by now much harder, but it's still sticky on what used to be the bottom surface. Number 3 is much less sticky, but it's pretty hard. Number 4, still sticky. Still deformable somewhat too. Number 5, still a bit sticky, but no longer deformable. And the control resin, of course, is still liquid. So, I'll see you guys in about an hour now.